what you should have done on this particular problem. So on this one, you should have taken the log on both sides. So you would have log 0.8 to the x power equals log of 4. Now that you have that, you're going to use the property of logarithms. And so where does that mean our x is going to go in this case? In front of the log. So x log of 0.8 equals log of 4. Now we want to get x by itself, so what are we going to do to both sides? Divide by what? Log of 0.8. At this point, you're going to type it into your calculator. So we're going to take log of 4, divide it by log of 0.8, and you're going to get about negative 6.21. Did y'all get that? Now, we're looking to check that our answer makes sense. Remember, if x was the base of a logarithm, it had to be positive, but it couldn't be 1. If it was the argument of the logarithm, it would have to be positive. But the power can be anything whatsoever. So if that's a power, it can be any number, so that is an okay number. So x is equal to negative 6.21. All right, so let's switch over to the next page. So on these, it's asking you, for each exponential equation, rewrite it in logarithmic form for part A, then solve the original equation algebraically and evaluate the solution on a calculator. So the first thing we're going to do, part A, is we're going to rewrite it in its logarithmic form. What would this look like? 6 to the x power equals 104. What would that look like in its logarithmic form? There you go. Log base 6 of 104 equals x. Now, can we do that in our calculator? No. Since that can not be done in our calculator, we're going to work the problem just like we did in the previous examples. So we're going to take the common log on each side. So let's just kind of fill in the blanks here. So we're going to have log of what? 6 to the x equals log of 104. Now you're going to use your properties of logarithms. And so what are we going to do with that x? Move it to the front. So x times the log of 6 equals the log of 104. Now, what are we going to do? Divide. So we're going to say x equals the log of 104 divided by the log of 6. Now, can this be done in our calculator? So let's do it. So let's take the log of 104 and divide it by the log of 6. And tell me approximately what you got there. 2.59. And that was a power, and the power can be any number whatsoever, so 2.59 is a reasonable solution. Okay, let's try number 2. So if we have number 2, on this one we have 1.5 to the x power equals 22. So the first thing we want to do is write it in its logarithmic form. So what's that going to look like in its logarithmic form? Okay. Everybody make sure you got that. Log base 1.5 of 22 is equal to x. Is that something we can do in our calculator? No. Since that cannot be done in the calculator, what we're going to do is we're going to take the log on both sides. So if we take the log on both sides to be able to solve it, we're going to have log of 1.5 to the x power equals log of, there you go. Now, what do we have to do with the x? Bring it to the front. So x, that's going to be log of 1.5 equals log of 22. And now we're going to say that x is going to equal, and what do we have to do to figure out what x is? So divide. So we're going to take log of 22 and divide it by the log of 1.5. So on your calculator, you're going to take log of 22 and divide it by the log of 1.5, and to about 2 decimal points, tell me what you're going to get. 7.62 is close to the correct answer. We're rounding off, so that's an approximation. All right, so I want you just to take a minute, and I want you to go through and do number 3 on your own. that one. So hopefully when you did example 3 right here, that you got something that looks, or an answer of about 3.41. Did everybody get something approximately close to that? Does anybody have any questions about how we did that problem? Okay, so let's just really quickly talk through number 4. Some of you may have already done it. So let's look at this one. Let's look at part A. So Lauren, can you tell me what you got when you wrote this out in its logarithmic form? Good. Log base 7 of 3.5 equals x. So we're good there. But we cannot do that on our calculator, so that's not going to give us a solution. So then we said, well, we're going to have to try the other method. So let's talk through what we would do. If we were going to use that method to solve, what would we need to do first, Aaron? Okay, so take the common log on each side. Log of 7 to the x equals log of 3.5. Now, when we have an x as a power, what do we have to do with that power? Do y'all remember? Move it to the front. So x times the log of 7 equals the log of 3.5. At that point, when we're ready to solve for x, Levi, what are we going to do to come up with what x is? There you go. Divide log of 3.5 by the log of 7. So if you do that on your calculator, you should get approximately 0.64. Did everybody get something that looked like that? Now, this is how we can solve logarithmic equations when we can't just write it in exponential form and evaluate it in our calculator. But what you might be noticing here is that there is a relationship between this expression and this one. Every time these expressions are equal to one another. So what you really just developed, even though you may not have realized it, is something that is called the change of base formula. So I need to